method. So very curious how you guys take it and make it into an instrument.
Yeah, thank you.
Thanks.
Thank you. Yes, so I think today we will focus on besides of our general philosophy, today we will focus on basically on two things. And it will be not only space and time, but basically how cities can be observed through space and time. I will try to make my lecture short, like 30 minutes, and then I want to participate in the discussion, if there will be any questions. And then we want to demo you our software, basically, because I think it's better to show in live software how our concept of blending space and time together works, and how it can be used from a user perspective. So the cities always were observed as a flat objects. I mean, this history of drawing city maps, I mean, it goes far beyond into history. But we really started to look into this dynamism of an urban environments pretty recently. And previously, the map as a spatial concept and the time as a temporal concept were completely is isolated from each other. And time was usually illustrated as a time series. So, for example, when money flows from your banking account to another one banking account, we can represent it as a time series. So, a series of a timestamp when the value is changing, and that's it. But while we are observing how city landscape changing, we always look at it through like a number of statical snapshots of its map. And I think that's pretty much workable concept. But the modern urban analysis, it's too complicated to be analyzed with like statical layers, because as a modern city environment can be looked like, it's a multi-dimensional thing, because we have a visible layer of a city, like we are sitting and we see these walls, roads, we can hear something, but at the same point we have this, I don't know, a money transaction layer when we, I don't know, some internet service charging money from our bank account right now while we are sitting here. And at the same time, we have an opinions. For example, if I say something, I don't know, good or bad, you can post your opinion into Twitter, and there will be also some kind of an environment layer that we are sitting right now. So there is a lot of layers, like a temperature in this room. It's also an informational layer, and all these layers coexist together and create this, what we call basically a palimpsest, an overlay of different informational layers on each other. The problem is that all these layers are dynamic. There is no static things in a modern urban environment at all. Even our buildings, which are the most hardest thing in an urban environment, are still not static because they age. And we redevelop them, I mean, we reuse them. Our usage of a space is evolving constantly through time. So there is no statical option at all. So when we start to try to fuse all these different informational layers with each other, we are getting into some kind of a problem, because all these layers are dynamical, and we need some kind of a tool which will allow us to blend and merge all these different layers together, but using a same like a thinking concept, how we think about these layers. And this is how Chronotope emerged. It's currently this image, I think it's a real mess. So it's 3 different data layers, as you see right here. It's mobility layer, so how people move through an urban environment. A sentiment layer, how people think or talk about an urban environment. And the spend layer, which is basically how much money they spend. But I mean, when we look at it, we don't understand it at all. But basically what we are looking at, it's a 3-dimensional map. A conventional map, but with a time axis, which goes way up. So hour by hour, we draw the new map of a city. I don't remember which city it is, just a fictional city. So hour by hour, we draw this statical map over and over again, and finally create this spatial temporal cube, as we call it. I mean, really hard to get. Everybody just get lost here. But let's reduce dimensions. Let's just look at the flat map for now. So here is our discussion topic. This is overcrowded Barcelona. Overcrowded by not local people, but the tourists who are not belong there. We used Twitter data to analyze this problem. And here right now you see this purple layer, which are probably local people, a little bit more widespread, and the green layer, which are tourists. And we just plotted all these things on a conventional two-dimensional map just to see how these layers correlate with each other. So the problem was, can locals and tourists coexist in a single location together? Because that's a conflict, right? Because when they coexist in a different location, in different spatial dimensions, they're all fine, they don't see each other. But when they correlate or intersect into a single location, in a single cell, because here we see cells like a 300 to 300 meter cell, just a spatial grid. So, I mean, when they started to intersect with each other, they started to see each other, started to talk with each other, and they started to share a space with each other. So let's dive a little bit deep into structure of a Twitter message. So a general Twitter message actually told us a lot about an population, because this can be used a proxy of an urban activity. We have a location where Twitter was used, which is, I mean, it's a good one, data. It allows us to see where person used his or her phone to post this Twitter message. But there is much more in this message. There is a sentiment in this message. It can be a hashtag where we can extract the sentiment via a neural network. So basically we can say, is this sentence in the Twitter message was good or bad? A binary, really simple thing. Or we can say more complex thing about which place person are talking right now. So we can measure what we call a semantic connectivity. So we can, for example, connect the place where I stay, and at the same time we connect this place about which I'm talking about. So for example, when I talk right now about Moscow, so I'm saying Moscow, I'm connecting this place with the Moscow, so I'm creating a semantic linkage. And also there is a topic. So for example, when I'm talking about Moscow, I can say that, the Moscow is cold. So I'm talking about weather in Moscow, and this is the topic of a message. So to get previous slide, we analyzed just locations in Twitter data, a really, really basic stuff. But what we did more complex, we extracted the meaning of this location. So we extracted, is this person was tourist or local? We did it by analyzing how often this person travels abroad. So if, for example, I mostly stay in Moscow, I'm local. If I was in Moscow 3 times and most of my tweets are from Barcelona, I'm a Barcelonian tourist who came to Moscow. And on this slide, we see a correlation between these two different data layers. So basically, we just overlay tourists and locals, and we see that there is a lot of places where they coexist. So the problem of an overcrowded Barcelona is, yeah, it's here. But is it really here? Is it here in space and time together? Because are these people are coexisting in the same temporal dimension, while they coexist in interspatial dimension? And Chronotope allows us to know this thing. We can just introduce this third dimension here. And now it's already a mess, but still we see a pattern here, right? So we now see this strange rectangular object, which I go down all the way. I mean, we make this slide like this for purpose, because it illustrates not our finding here, which we'll see later, but it illustrates structure. So when we look at a spatial temporal structure through the lens of Chronotope, we see these grids aligned in a time. So basically, each this rectangle here is a space-time beam which collected in itself an aggregation of a like, for example, 200 to 200 meters over a time, for example, for 1 hour. So if we sit here all together, like a 20 of us, for 1 hour, we will see a rectangle like this with a number 20 inside of it, which we can measure. And the darker these rectangles, the more people are in this spatial temporal thing. Let's move to this more illustrative picture here. So basically, this is how our space-time cell and or space-time bin can be visualized or think about. What is fascinating here is that by reducing these 3 dimensions into just 2 dimensions or 1 dimension, we still come to a conventional thing like a map or a time series, which I showed on my a second slide. So this blue thing, for example, it's a classical time series. So we measured a cell on the ground which is 200 to 200 meters, and then drill it down through time. So basically, this can show us that in the same area, in the same cell, was 20 people in 1 hour, 10 people in 2 hours, and so on and so forth. So it's a conventional time series. But while we remove it time dimension completely, we are getting a snapshot of a map, a conventional map, which is marked a yellow. We call this abstraction a time slice. So if we imagine this spatial temporal cube, where we have this all concentrations of people, I don't know, events, some kind of Twitter messages, or just persons who move through this space and time, we can always snapshot it and get a single time slice of it, a single map, and a conventional classical map. Really complex. But look at this, and you see the cube. And this cube is the same cube here. So you can somehow correlate it. But let's get the findings. Let's see how it's all allow us to see what is going inside of this overcrowded Barcelona landscape. So what we see here is the same matrix of concentration of tweets of local users of Twitter, basically conventional Barcelona, and the tourists. And this is how they coexist in a space and time at the same time. So at 1 a.m., for example, here is the time which goes up. And at 1 a.m., we see only coexistence in a conventional city center. And then when time goes up, like 2 a.m., 3 a.m., 4 a.m., 5 a.m., it started to grow in diameter. But still, we see that through all day, the whole concentration of locals and tourists in the city center, it's basically, it's in conventional central borders. And we see this some kind of sparks of activity of coexisting locals and tourists across the city, but they're like for 1 hour or for 2 hours. So if you go forward here and filter values, so this like a shaded image is what we had on the previous slide, and this bright image is the filtered one. So we filtered all low values and keep it only high one. And now we see that during a space-time through a day, the locals and tourists intersect in a really small part of a city. It's almost like a, I don't know, 500 to 500 meters, even maybe a little bit more. So there is no. So if you return to this one map here, it's basically the central green dot, or maybe this one, and that's it. So there is no real intersection, and we can see it here. So basically, there is no such thing like a broad coexistence of locals and tourists in Barcelona. They're all spread, but not spread in a temporal dimension. Or I'm sorry, not spread in a spatial dimension, but spread in a temporal dimension. And usually people wondering how we came up with this strange idea, and how is it really usable to analyze cities through such concept as a three-dimensional matrix? I mean, how we can use it at all? Because I mean, if you compare it with conventional maps, it looks completely crazy. But what we have in medical imaging, we have MRI, right? So when we scan people's body, and we can go inside of this body, because we can check body density by casting rays, and as dense area, as more value we have, as less dense, less value. So we are able to remove lower values and see inside of people's body. And we did the same for Chronotope actually. So basically we use it the same format as people using for medical imaging, the same concept, one-to-one, and applied it for events or people's concentrations inside of a city in the three dimensions, spatial and temporal. And here is another example of Barcelona, but we did just cut it and get only one street, just a single street here. And we visualize the concentrations of tweets on this street through time. So basically the darker area, the more tweets this area has, and the lighter area is less tweets this area has. But is anyone knows where is the bot, a computer software which tweets advertising messages? Can you spot it here?
A column.
A column, that's correct. Yes, because the software has inhuman behavior. Because, for example, here we have a classical day-night break, right? So here is the 3 a.m. and here is the 6 a.m. And people are sleeping in this area probably, so there is no data at all. And here we have a pattern which is changing over time. So we have like an intense moment, and we have also moments when nobody uses Twitter at all, like at 9 a.m. At this region. But here we have a constantly a constant value which almost doesn't change over time. So it's like a tweeting because it's an automation. Of course, people can make it more smart, but it was unneeded, and it's really easy to spot this visually. Somehow I don't see my slides changing. Okay, I will do the mouse. So, for us, the other question I think which comes here and stops our understanding of a Chronotope is a battle between a classical shape as a definition of a space and a grid-based system. And what is interesting for me here is that we can just look at these two pictures and put this space, a classical JS shape file, on top of this grid. And it will fit in. So basically this grid concept, it allows us to explore or draw more complex thing, not only like grids or squares. So we can actually, in this rectangular grid, we can put any kind of abstract shape of a city, putting it and encode it into this thing. So here is how our Chronotope works again. We have this map dimension, which is basically a conventional latitude and longitude. And times goes up. And here is the grid. So basically we are separating the space again into the small cells which we fill with the concentrations of any kind of data, which has obviously only two things: geolocation and time. And this allows us to correlate actually an arbitrary data with each other. So for example, we can see at the same time when people spend data in a space-time and still see how they move in a space-time or how they feel about the space. because every information which I showed in my first 2 slides are encoded into this matrix on here. So basically, using the same concept of thinking about information in more unified way, we can correlate it with each other really simply. I mean, it creates us some kind of a universal thinking environment where we can not only limit ourselves for a single type of data, but actually use almost any data available. Even if you think about an classical grids of cities, and when we imagine a buildings inside of the cities, we can just illustrate the cities and buildings inside of it as like a statical structure which goes up and never change over time, or change if we have like a long data set and we know and we see how buildings are demolished and popped out. And this is an actual Chronotope. This is an interface that we created, which works in any browser. It's easy to use, and we will show it to you in like 5 minutes after the questions. Thank you. And probably you have some questions, right?
If you don't, I can talk for a little bit, but yeah.
Traditionally on maps, when you look at the third dimension, you look at geology and geography, which play an important role in cities as well and in data. How do you resolve the conflict between time as the third dimension and geology or geography as the third dimension?
Yeah, that's an interesting question which everybody asks us, and I don't have a direct answer which solves everything because as an urban experts, we don't work with geology at all almost, because we work with this hard urban environment, and also we work with a soft urban environment which is inside of this hard environment, right? Like how people move, what they talk, how they spend money. And if we talk about geology as about like a single layer which changes over time, it can be integrated. But if we need a third dimension, like how deep some materials are, no, we don't. And I'm actually wondering, is there any example maybe you can name which really needs this? I mean, in the general study.
Well, in some ways we can do it, simulate it. Like, let's say it was building height, we would just use a static layer that's 1 square represents 10 floors and 1 square represents 5 floors. But to do that visually and like overlay a base map that had this grid of New York would be kind of misleading, because the grid would be hours and building heights would be kind of confusing. But you could maybe represent it visually with some kind of post-processing by merging these together. But we're not integrated with like Rhino or anything like that to where that is something you could do at the moment. But yeah, I mean, if you do have any ideas, let us know. It's a great question. I mean, I think about the same things with use cases around like global warming and like coastal flooding and things like that, because I think that's super relevant and has the whole topographical component, and that's environmental and built environment type of stuff. Anyone else?
So something you found that you've not been able to measure, or something that you hope or dream to be able to measure or visualize in the future using new technology?
You mean like an unexplored things?
Yeah, something you just found was more difficult than you thought, maybe, or...
I think the culture is an interesting thing to visualize and analyze. We did a single project about like a cultural analytics when we researched in Denver Performing Arts Center, I think, yes. And there we visualized how people talk about the culture in 2 different data sets. We analyzed the Twitter data set as an example of like a general culture, or culture that everybody is used to, and of course in a social networks projection. And at the same time, we analyzed the Wikipedia textual corpus. So again, we compared a Wikipedia and a Twitter, and we did a simple thing. We extracted multidimensional representations of how words relate to each other in different corpuses. So we basically we're analyzing how, for example, term culture relates to other different terms in this multidimensional space. So basically, we can visualize this like dots in the 3 dimensions, and every dot is a word, and we analyze these clusters of these dots. And in a Twitter data set, it was really funny to look at because, for example, when people talked world culture, they usually meant like, let's go to see cinema. It's obvious, but at the same time, it was like, let's have a coffee near the theater, or let's hang out in a museum. So basically, culture for them meant not only a conventional terms like in Wikipedia dataset, like when you enter culture, you see cinema, or you see, a dance show, or something like this. Culture for them meant a certain lifestyle which they are used to. And for us, I think creating some kind of a universal tool which will be able to analyze culture in all its dimensions, like in visual dimension and in textual dimension, is almost the next frontier. And the second thing that we are working on right now is an lower scale analytics. Because this software, Chronotope, it focused on a city level, but we are really interested in analysis of smaller things like office spaces, for example. Because the modern office spaces are almost like a cities. They have their own structure, and they have, especially because it's a really communicational device for people. They have this special format of communication. And if you compare it with cities, the mutations of communications while they're changing the landscape are bigger. You can change just how 2 seats are connected with each other, or how it's located in a space, in an office space, and you will see the communication change between these people who previously seated close to each other. Or, how spaces are intersect with each other, how they flow into each other. They all affect communication, and it affects an office culture or working culture, and at the same level. And for us, it's like a next frontier to analyze, because it's really hard to get good office data right now.
One other example that I've been thinking about lately and talking to our clients about is identifying groups that are difficult to identify in the city, like the unbanked, or people who use cash for all their transactions. And using our common denominator, you can find several different data sources, because although people may not have a debit card, cell phones are ubiquitous at this point, even among those people to some extent. And so you can use that layer and abstract it against the spending patterns to identify these people, and not only like where they are, but where they're spending or not spending. So that's one of those kind of hidden gems that you can find when you dig a little bit deeper. Someone else, you had a question, yeah?
Yeah. I have a question from information and urban perspective, the entropy of the city is increased because
That's true.
The parameter is increased now, and also the technology is involved in this conversation. But if we do this kind of technological explanation, it's like we want to reduce the entropy in this conversation. So how do you see the balance of these two? And the second question is, you're using the matrix to simulate the situation in the city, but how do you think of the limitation when you're using the parametric way, like you're building a matrix? Because this matrix is more like 3-dimensional representation of a data, but how does that data representation means to like a real urban, maybe morphological topology?
interesting. Okay. So no, I can answer. I have a broader background.
Yeah.
The first one was that entropy is increasing, right? But the structure of an urban environment that we are showing, it's more, it's not so entropical displaced. Let's name it like this, correct? And how we can, and what we're dealing with is increasing entropy at all. So I think it's a hard question because if you think in our mind about always increasing in entropy, we imagine an chaotical environment. Something with a lot of like a sparse object, right? That are flowing through this three-dimensional space. If you visualize them in the cube, as we're talking about. And here we are like aggregating everything into more structured cells, and it looks not so chaotic at all. So what I think is that this visual representation doesn't illustrate entropy at all. And when we think about entropy and why it is increasing, I think it can be increasing at some point because we are introducing a lot of input parameters into the system, right? So basically, what is a chaotic function? It's a function which really depends on an input parameters. And when we are starting to illustrate city as a multi-dimensional model, it's really easy to go into this chaotical function or chaotical model, right? Because if we like stack too much layers here, at some point we will not understand the consequences if we change one value. But this is why I think predictive analytics are not working well on a city level. Because, as you said, entropy is increasing. And it's increasing not just over time. It's increasing while we add our understanding into a system. So basically, while we were at, medieval ages, and there was no data at all, it still was there, but we didn't analyze it. You can measure the drug level, the drug usage of population by analyzing the water in canalization. Okay, so the city water.
Yeah, that works.
And that's the thing. So our data-driven cities, they're not data-driven by technology. They're data-driven by our understanding of cities. So we started to think about cities in this data models. So we started to think how these different data layers are laid out in the world system. And this is why we started to understand that, suddenly the system is too complex. And while we're introducing new and new layers into the system, the entropy of it increasing. But it was always like this. We just didn't add these layers, additional layers. And these layers, they're not always digitalized. Because if you also analyze the garbage as a population growth proxy, it's the same thing. So you can analyze the amount of garbage which people drop to streets, and it will somehow correlate with the growth of the urban environment as well. And the second question, I think, it's totally related to the previous one, since this structure, it's fully gridded, and how it's grid of this matrix replicates or forces us into morphological decisions, correct? It doesn't force us at all, because there is a field concept in it, which I didn't introduce you, but thanks for the question, because this presentation, it's more like a conceptualized, so we are trying to show a single concept. But what we came up with at some point is that, for example, when we work with the Twitter data, you've seen it right now in the previous example, right? We work with a sparse data. So basically, when we visualize Twitter in these 3 dimensions, we didn't get this beautiful field cube, right? We get a lot of small dots. And that's a coolest thing ever that we stuck with, because at some point we understood that this tool, it doesn't work. Because it doesn't form this good-looking dense array of data at all. And this is how we came up with a blur, basically. So blur here, you see how user of the software applies blur. It's something like a Photoshop blur. So if you get an image, right, you can blur it and make edges of this image more, I don't know how to say it in English, blurred. So but basically, what you're doing, even in Photoshop, you're taking a strict structure, right, and blurring it. You're converting it from a structure to a field, actually. And this is how a field thing works. Basically, we are not illustrating a direct impact in a space-time. We're illustrating a field of an effect. So we're illustrating how possible event in a space-time or even on a map, when we see a heat map, we see it like a possible dimensions. And it's always not a strict like a grid structure. It's always a field. And fields doesn't have any boundaries at all because it's a soft structure. And it's really correlates with our understanding of a modern and reusable space. Because as a space, usage can be changed. For example, we can renovate old factory into offices, right? The same thing can work with an urban structure. So, for example, when we apply an effect into an urban structure, for example, I don't know, just build a monument. We didn't create an event in exact place, in exact location, and in exact time. We created a field of an effect, which grows through space to some point and through time as well. And this is how it's, I think, affect the whole urban morphology. So it creates a bound for you, but it's not creates a strict bound. It creates a soft bound, which you can even not touch. I mean, these bounds even not guide you in your forms or urban in form decision or urban planning decision. It just show you the possible way to go. And this is, I mean, a really new concept for us. It's like when I think you're familiar with Christopher Alexander works, right? So there is a city is not a tree, where we illustrate a city as a consequences of one object applied to other objects. And so basically, it's all, you can imagine the same thing, but in like 3 dimensions, like also in time. So when you apply some kind of an event into space, it grows, because it always correlates with other events, with other movers through this space-time landscape and affects them.
So, yeah, because you mentioned Christopher's city as a tree, because in his article, he said every contact as a
yes.
indexical information, and that indexical information is being activated in the scenario he described. But in this way, I feel like you said, it's a softer, like a process.
Yes.
I understand this as a deviation of the data. So how do you understanding of that deviation process?
Cool
because
question.
That deviation process sometimes means a lot. Like maybe on a data level, it just means the blur or like the transformation you manipulate with the data itself. But if you metaphor this to a city level, it could be a very specific city strategy, like Christopher mentioned. It's a very specific thing. So
and that's a cool thing. I mean, when you mean the structures that Christoph mentioned, right?
Yeah,
on a structural level.
He used very specific indexical hierarchy to describe the
structure, because it's a series of consequence events.
And then when he do this, this tool is like a topological.
Yes.
Topological reflection with each other, like data.
Yes, but
now this one is a little bit, because you did
it's better to draw actually. Can I draw? No?
Right here you can.
Yeah, there's one behind that.
I don't have an architectural background, this is just how I understand it. So basically, in Alexander world, it was like first this. So this is basically a tree, right? And then he produced a semi-lattice structure. This is when all events that I feed through my path, for example, I start here, went here and here, they are somehow intersect. So for example, when I move through road, I see a tree. And this tree somehow affects my understanding of this tree. This is how I understood this paper. So basically I can be not right and not like so academic. So basically we can imagine this. A lot of intersections of different events. So, but still keeping a topological form. What my vision of it is that we have a different journeys all the time. This is the second journey from the same street, but this one was at 13 or 1 p.m. and this was at 2 p.m. for example, when I went back home. And this is like two time slices, but these time slices are correlated, like this. So all events are happening simultaneously. And at some point, it's starting to look like a mess, because there is no structure in it at all. This is why we imagine it as a field. Something like this, which is really hard to draw on this vertical image. But if you go, for example, in a 2 dimensions again, but not into events, but instead we can go to map, like this one. And this is again an event, not an object, events, which are not happening in time but just in space. And here is a field. And now you can scale this field in 3 dimensions. So basically when you are getting this map over and over again, over time. And this is how, we are moving from this strict structure, a really topological one, into something which even, I cannot draw it. It's more or less like a heat map, a traditional heat map, where we calculate a concentrations of something, right? For example, of people movers. But when we go from like a physical object, like cars or dogs or whatever, into first something like an urban mover, which was introduced by Christopher Edson, Thorsten Hagerstrand, a geographer who actually invented this special temporal prism. And it was a concept of an urban mover, like an object who moves through space-time. But then we can go to more recent works, like I don't remember his name. There is a guy who researched 3-dimensional visualizations, actually in space and time, with the second name Andrienko. He's Russian but lives in Germany, and he also introduced that there is not only like an object can move through space-time, but also an event. For example, I don't know, a tweet, right? It's an event in space and time. But we can go further, really further, and not only visualize this object, but also go to Christopher Alexander Beck, right, at the beginning, and took this like emotional things, like how objects correlate with each other, and also visualize it as this field. So basically, my understanding like this, but I didn't still create a good layout to talk about it. Any more questions?
Yes,
Is this a standalone tool, or are these interactive visualizations, are they exportable to be incorporated into other applications, websites, things like that, as part of other analyses, or is it just you have the data and you can work, you have to stay inside this tool?
Yeah, it's can be export it into classical JS software, for example, as a shapefile. You can also export data in a tabular format, but it's not public yet. Also, we can export the screenshots, of course, but the problem with this one is that you cannot just embed it into a website like with a cartoon, for example, map, because it has a little bit complicated technology underneath, and when we are visualizing this special temporal view, we actually need a lot of computer power to analyze it interactively, and because of this, we are rendering all this image on a remote server. So it's streamed into browser as a picture. And this is why, I mean, for us it's really expensive to embed it into high-load websites. And also this is the reason why the software for a long time was a strictly corporate or in-house tool. And only recently, like, basically we opened the login form just 3 days ago or 4 days ago. It started to become public, so we are really at the early stages. And I hope Nikita's demo will show how it works.
Anyone else?
What are other real-time applications? Like you mentioned analyzing various offices, and I know you have analyzed, I don't know if I'm allowed to say this, but I know you've analyzed Zaha Hadid Patrick Schumacher's office in London.
Yeah.
What did you discover?
It's you don't supposed to know this.
Oh. Supposed to know, okay. How about other uses?
But there is a public project.
I'm joking.
There's another project with Hadid called Walkable London, and that was about understanding what streets are best for pedestrianization. We discovered that some of the areas they're proposing were not necessarily the best, where like the kind of obvious ones, the Oxford Circus area did make sense, and that's being used to kind of lobby for the pedestrianization of these certain areas. That was a hybrid of several different data layers. I believe mobile phone data as a proxy for density, things like street width, and I believe there's one other. Anyway, we can show that in a minute. Some of the other projects we've done recently, event impact is I think a pretty interesting one. Chelsea Stadium, this one's on our website, but what's the impact of adding more soccer matches? Is it something that is just overwhelmingly positive for the community, or is there something underneath that should be further explored? So we used Google Place data, overlaid that with Twitter data, and tried to see on the streets where there's local businesses, what is the activity on a match day versus a non-match day? And so this z-axis here, which is time, doesn't have to be strictly chronological in a normal sense. It can be divided like on a rainy day versus a non-rainy day and stuff like that. And so what we found was on match days, all the activity was focused in touristic zones and the match. And so the theory is basically that if you add more matches, you'll give more money to this greater area, to the area, but it will be concentrated in those places. So the local economy for the people who actually live there doesn't actually truly benefit. So the way we saw that is we correlate regular day versus non-match day. There's tons of activity on these normal streets that have all the regular business, and on the match day, those streets are somewhat empty, both spatially and temporally. But typically, even more so on the normal operating hours. So people tend to actually be kind of avoiding those areas. Some of the other real-life applications that we haven't done yet that I've been talking to, emergency response I think could be cool, like identifying, populations that are difficult to identify, like the hidden, the cashless transactions, refugee populations, things like that I think could be interesting. Other projects that we've been working on for cities, I think, again, like just urban infrastructure decisions on where tax dollars should go. Like, should you build a new stadium in the first place? Or is a museum in this location versus another location practical? Does the audience have the capital, and are they spending the capital necessary to facilitate the museum's attendance and structure? How much should you charge? I think the use cases are really broad, and if you look at our work, you'll see that our focus is pretty broad as well. So trying to narrow that down from a business perspective is kind of where my work lies. And I actually think I left your question completely and started just yapping.
It's okay. No, this is very interesting. I found like the kind of my original introduction to the idea of Chronotope was just very simple sort of moments that we maybe notice as architects, but we don't necessarily know exactly what to operate or how to operate on that. So for example, you have, I don't know, a series or many parking structures in the city where they're really busy during the week and then they're empty on weekends, for example. So could those be used as markets, which is something we see on, let's say, I don't know, it's a 26th Street structure that does that, for example,
right.
or even 6th Avenue. Or are there, restaurants that are really busy at night and then totally empty in the mornings, and then the space could be used for community classroom or offices, or something like that.
There's a business doing
so
that.
So there are all the sort of operations that begin to think, work with space, but not necessarily in the kind of classic architectural way, but in this other Chronotope.
Right. Well, yeah, I think time is becoming more of a commodity. WeWork shows that. This company, Spacious, actually does exactly what you were just talking about. They use restaurants as office spaces during the day. They're based in New York, pretty interesting company. So yeah, this whole idea of the time economy, I think, is brand new, and I think Chronotope is prime for that exact business model. But it is quite a new concept. Right now, the idea of time and its use in the city is most obviously applied to traffic and congestion and protests and what those mean for the city. How do you react to them? How many people do you need to support a parade and stuff like that? And that's in the whole kind of event impact scenario. But this time economy, I think, is a new opportunity that something like this could really be helpful for.
On a large scale.
Yeah, absolutely.
Even on a small scale, I mean, inside of offices, if you someday come up with a scaled down solution, it's also time is pretty much valuable, because this, especially if we're talking about huge offices for an IT companies, I mean, it's a series in itself, and how we reuse time in these spaces is also important. And also this important thing for us, communication inside of offices, which is also what Patrick is focusing on. I mean, it's clearly differs from time of the day, and designing a modern communication devices is also a question. It's not only about how the static structure works for communication. It's also a matter of how communication evolves through time in this structure. And this is also this concept can be used for. And but I think the general idea is that the use cases are much more broader than just reusing someone's space over time, because this tool it's more complex. It's too much complex for this task. And I think that we wanted to create Chronotope as something like a general building block for various analytical solutions which involve time at all. So I hope that different use cases will pop up over time, and we will have more use cases which are not so marketing oriented, because I mean marketing I think is our starting point, and now we are starting to go deeper into this effects of our interventions. And finally, when someone will use Chronotope to support his planning decisions, for example, over time, I think this will be groundbreaking, because we will finally see how a person or a group of persons can use our tool to guide some project over changes over time. And if the period will be long enough, I think the use cases will be not so obvious.
You had a question?
Yeah. So we're kind of dealing with a similar set of data right now, which is from Reddit, and then we also have a time axis, and then we've been thinking we think the scale in time is very different from the meaning of scale to a physical space, because when we look at time at different scale, we feel like we're looking at different subjects. Let's say if it's hourly slots throughout the day, then it's more of a collection of individual habitats or reaction, but based on individuals. But then if it's daily or weekly time slots, that's kind of general gesture for a mass population towards certain events.
Yeah.
Do you guys have any reflections on like how do you guys choose scale on time?
I mean, it's problem focused. I mean, if it's the software is built to be adaptable for that exact reason. So we can have our z-axis be daily, hourly, monthly, weekly, whatever. And I mean, I think it just is based on the problem that people are trying to solve. I mean, obviously, if you're talking about commuting, it's going to be an hourly or minute breakdown, where a daily breakdown would be a lot less. Might make sense if you're talking about the impact of a holiday or weather, but if you're talking about just the general start time of a commute, then you need to look at it hourly. The hybrid of those two, I'm not sure. I think there might be like some use in that, and we do that by using approximated layers, which I think like Nikita or Vadim could speak to a little bit better than I can, but essentially like if you wanted to look at the hourly breakdown in January altogether, you could pull all of the data from January daily and show the 24-hour distribution there, and then do the same thing for February and play them against each other. So you can see that February, the commute started at 6:15, and in January the commute average started at 6:20. So you end up kind of making a hybrid in that way. Otherwise, you could just do a sequential study, which would just be hourly over time, which would end up having just like way too many slices and be hard to comprehend. But sometimes that can be interesting too. Like I did that with Airbnb data in London, and you ended up seeing this tornado, like from its growth, which is like super obvious because the company grew, but it's something that from a visual perspective you couldn't see if you did the approximation. So it actually takes a lot of hands-on manipulation to truly find what way to look at it. So you kind of start with the challenge, approach it in one angle, but then try some other angles, and you'll find maybe new, undiscoverable, or less readily apparent insights just by exploration. And that's kind of one of the core principles behind the reason we built this web tool, is this idea of dialogue. Like the way we see data right now, even in the kind of New York Times type visualizations, which are really beautiful, is still very prescribed, even over curated, to a point where it's like there's some slight, I can turn a filter on and off and see like where different demographics live, but I can't really truly manipulate the underlying structure and really configure it. So we've tried to, or these two, have tried to build something that's highly adaptable, so that you can, push your use case in whatever way makes the most sense.
And if you talk about like a value scale inside of the cells, right? Like Wiliam talked about a temporal scale, but also if you look at this in terms of values, we designed this tool that the value inside of the cell are not so important as the correlation of this cell value and the nearest neighbors of the cell. Because I think we don't really actually need something like, okay, this spot has 20 people or this spot has 10 people. We need to know that this spot has twice more people than this one. And next we can scale it. So we are always thinking relative. We always can extract the real values from it, but we, for purpose, hidden this feature. And our base tool are always relative.
Follow-up question to his question. The data set he's working on, one of the ideas they had was coming up with the sort of topology of Reddit. There's no physical map. Well, could
IP addresses? No?
Well, like, because I was very inspired by, I saw a topography map made by Mobike, if you guys know them. So it's basically a map of Shanghai, a topography of Shanghai in terms of how bikeable each street is. So it's all based on their data from their bikes.
Yeah.
So, and they have that for different time slots during the day. So then, meaning some of the topographies, let's say it's really hard to bike, is created by traffic, which is created by people in physical certain time slots.
Sure.
And that to me is like one of the goals that we possibly want to achieve. But then, yeah, there's we just lack of we lack of physical coordinates. Two, because of that, then the time we have on each Reddit becomes less physical because of the time zones.
Right.
Yeah.
That's tough.
Yeah, but there's a question of understanding, and I mean, how you envision this. So, for example, if you look at this landscape not as a physical landscape, but a communicational landscape, you still can visualize it. I mean, Chronotope currently it's so binded to a map, but I mean, you don't need a real location to visualize an landscape of some kind of communicational relationships, because you just need to when you're visualizing it, you just need to decide what is your like a spatial dimension. I mean, what do you project onto it? And temporal dimension, I mean, it's obvious, but I think your concern was that your time and temporal dimension at all will not so affect like a real usage of this. I mean, don't affect real users, right? Don't show how they communicate, because it's this time don't relate to space at all. But I think it's a little bit. It really depends on how we think about this imaginary landscape. Because I think if this post was all done in a single environment, and if these users of this system coexisted during the single time frame, this time 100% relevant. And yes, they not like existed all in a real space. It just was in this communicational abstract thing where they communicated with each other. But still, the time when they communicated, it really matters. And also, these fictional locations that you will create will illustrate 100% how it's related to time, because it will always be time related. So, if your data set doesn't happen in space, it doesn't mean in real space, in a physical space. It doesn't mean that it doesn't have a special dimension at all. For example, when we analyzed Twitter for the first time, we did a simple trick. We not visualized when people used Twitter, because in Moscow at that time period, it was like 2013 or something, was not so many geolocated tweets at all. So we just collected all tweets that we was able to get. And what we did, we extracted the place names about which people are talked in a Twitter, and then geocoded these place names on a map. And by using this trick, we are not visualized a map of when people or where use Twitter. We visualized about which places people are talked. And even we introduced a temporal dimension. It actually was a prototype of a Chronotope. And we aggregated this Twitter data layer by layer during a weekly period or something like this. And it was our temporal dimension. So we created what we then called like Moscow semantic periphery, which we obviously I think when all tweets about locations was so central, so people talked only about the center of Moscow and didn't talk about periphery at all, which was for us a little bit counterintuitive, because we thought previously that it will be more or less widespread, but we have a clear center, as with Barcelona actually, but it was a different project. But a periphery was empty. But periphery in Moscow, fix me if I'm wrong, it contains around like 70 or 60% of Moscow population, right? But in terms of communicational layer, it was completely desert. It was emptiness, and that's raised our question about how we can analyze this, because I mean it was in terms of Twitter analysis, it was completely empty. But it's not only was a problem of analysis of it. It also was a problem of for example, public activism in this area. It was nothing like this, because people didn't discuss this place not only in a Twitter dimension, let's name it like this, but also in public talks. Because this project, it was strictly connected to an Moscow Urban Forum, where one of a government representative told like a phrase that changed my understanding of such type of analysis. He told that why you are so concerned that in Moscow we have an culturally underdeveloped periphery. So there is only residential buildings there and no type of activities of other types. And he told that nobody complains because everybody. So I think that everybody likes it because nobody complains. And I mean, it was hard to argue with him because there was no evidence of such thing as a complaint. And this is like for me like a merge of the semantic landscapes and the real landscapes that we have. So when we have a desert in terms of communication about landscape, we also have some kind of a problematic environment because nobody communicates about it. So the problem is not only when environment makes our communication harder inside of it. The problem also when we don't communicate about environment at all because it also don't allow us to to spot problems actually.
Yeah, I think you mentioned time zones with the Reddit data in that sense. Like, if there's no geography attached to the time and it's just an hour, 12 is in one place and 8 is the same, and you don't know the difference, then I think you'd be just stuck with more aggregated, because there's no real correlation there, right? Like, unless you can do what Vadim's talking about and pull out some sort of location value. I don't know. I was thinking about an idea of, I don't know. I saw this Federer versus Nadal map the other day, and I thought it would be an interesting thing because it's like looking at the tennis court, and you could maybe like apply the same type of logic to different types of geographies and think of the tennis court as like, you know, the Reddit tennis court or something. But that's maybe getting to
complicated.
a bit of a reach. But anyway, I mean, you should do a trial, first of all, and that type of use case would be perfect for us to explore. Like, I don't think we've ever done anything with Reddit, but Reddit or Yelp or anything like that where there's lots of text data, trying to assign a space to it, I think is definitely like within our interest.
Mm-hmm.
I don't know, we're running short on time on the demo part, but if there's any more questions, happy to answer them. Otherwise, Nikita, maybe like a really quick run through just so we can look at New York or something.
Mm-hmm. Yeah, I will do the talking, you will do the clicking.
Yeah, just my throat is
Can you ask, do you want to take a question?
Yeah, go for it.
Sure.
Yeah.
Kind of simple, short question, but how do you address issues of privacy in your work, especially with the big data and like user data?
Yes, beautiful.
The data providers do part of that for us because they have their own rules that they have to follow on a kind of country-by-country basis. Like for cell phone data, for example, it has to be already aggregated to clusters of 15 people, and some companies that's 20. Or more, right? And so you can't track individuals in that case. And, you know, transaction companies have their own ways of extracting the data. And then on our own side, like, we can take the data and then convert it into an aggregate form, into these voxels, which further obscures and kind of makes it almost impossible to reverse engineer. And that's a requirement for almost any of these companies where you're using their proprietary data. And actually, one of our selling points is, because in the end, the voxel itself is like just
aggregated abstraction.
And yeah, it's just an aggregated abstraction. That's our unit. Like the fundamental component of our software is privacy focused by design or security focused by design. Yeah, which has like its own limitations. From, you know, it'd be nice to be able to reverse engineer these things and stuff like that. But again, with the data providers that we're working with, that's not an option. Mm-hmm. Yeah. Go ahead.
Yeah. So basically, as we told you before, our tool Chronotope is open, and you can go to Chronotope.io and sign up for a trial period. It basically allows you to trial it for 15 days. If you do not enter your credit card, or you can trial it for 30 days if you input a credit card, and after 30 days you will be charged, I don't remember how much, it's around 29 USD. Yeah, and for students we also provide some kind of an educational grants. So if you're doing an research for a project which somehow involves time and urban environment, you can always write us an email and ask for a free period of usage for this project. I think that's it. So Nikita opened Chronotope. He already registered here, and when you open Chronotope, we always have this what we call environments. It's basically a series, but can be something else. Now, because it's just a groups of projects, like a folder. And here we have London, Moscow, and New York environments. Also have some kind of Milan environment. I don't know why it is here. You will not have it. And in New York environment, we have this three projects, and we just open in the first one, and you see how it's loaded. It's basically an multiplication you see right now of a social media activity and points of interest. Social media activity is a Twitter data that we bought or collected from Twitter, and the second layer is the points of interest. It basically show us when places are open over time. So, for example, if a cafe is open, it will be here, and if it's closed, there will be emptiness. So we collected this data over New York about which places are opened and where, and when, and where, of course, and now multiplying it. So basically what we see in this composite layer is the space and time when both of these type of layers coexist. So when we have an open businesses of a specific category, and at the same time when people are using social media. What it illustrates us is that, for example, we can have a place in a space-time where people are super active, but there is no open businesses for them. So this is a classical opportunity to open some kind of a new shop or something like this. But otherwise, if our shop is opened, but there is no people in this space-time area, it means that maybe we can reduce its working hours or reuse the space as we discussed before. So, for example, we can lease our shop for a temporal office space during the time when there is no active community around, which is, can be clearly observed on this three-dimensional map. And we can manipulate these histograms, the windows of histograms on the right. So basically we are filtering values, and we see we can filter the lower concentrations and high concentrations. So for example, when Nikita moves this slider straight to right, he is filtering the places where not so many businesses opened, and right now we are looking at the spots where at least 200 places are opened, and up to 8,000, which are still also anomaly high value, and it can be also filtered. So while Nikita is filtered it so much, we found this like a bright spot where we have relatively high social media activity, something like 7 posts per hour. And right now 41, 49. But at the same time we have a lot of venues with type art and entertainment in the same time. So, but basically, for example, if you want to open a new art venue, we can look at the high concentrations of media activity and the low concentrations of art venues, and this can be an opportunity. And of course, it's like a little bit too simplifying, because of course we cannot create this type of business in isolation. When we click and put this kind of a marker here, we are able to see full statistics over 3 different layers in Chronotope. So always forget these columns in the inspector. So basically, this means that in current time interval there is.
It doesn't make much sense in the spatial temporal.
In the spatial dimension.
In the spatial temporal. Outright you want like that.
Okay.
A radius.
Yeah. So basically, we see here different statistics over this selected region, and we can select this region not only as a spatial object. So right now Nikita created a classical like two-dimensional object, a marker, which hits a specific area on a map. But we can also select like a temporal area to see, as I showed you before, like a time slice or a single period of time statistics. And also we can select a spatial temporal region. So for example, if I'm interested in a specific place and want to see how much people was there in a certain hour, I can also do this via this spatial temporal marker. As we discussed before, we have different instruments for map filtering, like an classical JS primitives like polygons, radiuses, and all these things. And we can internet connection, that's good. Okay, yeah, and we can also apply this type of objects on a map to select areas of interest or specific regions that are important for our research. I think this like covers all the basics because it's a really simple instrument actually, and the hardest thing is to understand this spatial temporal concept.
Maybe show them the edit so that you can see how you can like change the environment setting or something.
Edit of
The edit like above the range, like the.
Yeah, here.
okay. That's very
I just think it's interesting.
Yeah, so basically right now we are working with a project which we call an approximate project. So this is a project when we have a data from a different periods of time but aggregated into a single day. So basically we can manipulate the time axis and aggregate data into like a virtual day, right? When, for example, when we have 1 hour IM, we took data from a different days and from 1 hour of these days and calculate a sum of this data or an average. This allows us to see, and as Wiliam described before, an activity patterns over time, but through the different, for example, months. So we can create 2 different layers here and compare each of these layers, but these layers will be not different data sets. This will be different time periods. And we can correlate these approximated time periods with each other to see how, for example, a March time usage over a single abstract day compares with a February time usage.
Here's July.
Nikita is showing it right now, and we will wait until it calculated. Yeah.
So I'm based here in New York. If you guys want to talk more about this, I'm happy to have you guys to our office or come up here. You know, we're kind of open to doing creative things with the academic world. So just please reach out. I'll leave some cards and stuff like that. And you know, I'm not meaning to cut it off, but we are, I think, about out of time. So you know, thank you, Anya, for putting this together. This has been awesome speaking with all of you guys, and thanks for all the great questions.
Yeah,
as well.
thank you.
Cool.
Thank you so much.
Thank you.
Thanks for all your questions, guys.